we're rounding off simple harmonic motion. But I realized that there was a particular kind of question. It's actually quite simple, which I'd skipped over, and would be very easy for me to demonstrate to you, but it'd be remiss of me to not actually show you an example of it, okay? It's where you get the characteristics of simple harmonic motion and all the different equations, right? Which we're used to calling this. But you get it for a situation which is not about things that are moving at all, okay? So here's the example I'm going to give you. Like the questions that I really like. It's a very simple setup with very, very little information, but you can ask some very profound things about it, okay? But we won't spend too long about it. There's a town, and in a particular time of the year, its temperature fluctuates between 13 degrees and 23 degrees. The coldest time is 4 in the morning, and apparently the hottest time is 4 in the afternoon, okay? So the question is, if the temperature exhibits simple harmonic behavior, it's clearly not motion, there's nothing moving here, okay? The simple question is, well, we want to know when the temperature is certain numbers. So the kind of numbers I'm after are, number one, when is it 18 degrees Celsius? And when is it 15? That's all I want to know. Okay. Right. So, how do we begin this? I'm going to give you 30 seconds just to make a start on it. Where would you pick your starting point? That's all you've got. That's all the information and the fact that it's simple harmonic. And that's all of the question. So, where would you begin? I'll give you some time to see if you can make a start, and then we'll come together and compare. Where did you begin? It's a very simple setup. There's very little information, so we have to introduce some things, right? Come in.
Can we borrow a marker from you?
A marker?
Yeah, we're out of.
Yeah, sure. Take both of these, because I don't know if one will last.
Okay, it's this bar.
That's fine. Which room are you in? Which room are you in? Okay, no worries. That's fine. Okay, thank you. What was the first thing you wrote down after the question? Sorry, say it again. I heard a few different things, but none of them were clear. Anyone? No, seriously, this is an important question. What is the first thing, what's an appropriate place, an orderly place, to start off your approach to this question? I can think of a few different places to start. Extremities. Okay, you wrote down this word. Then what did you do with it? What does it mean? Highest, lowest, or furthest in any direction, right? Well, these are your extremities here, 13 degrees and 23 degrees. And it fluctuates between those, okay? Now what?
Graph it.
Okay, I would like to graph it. I mean, I did ask you to draw a set of axes before we started, right? But before you do that, you need to, I mean, I don't have an equation. I've got nothing. Like, what am I graphing if I am graphing? I've got a horizontal axis, right? What did you call your vertical axis? Capital T for temperature. Not a bad idea, okay? Which means that I suppose these would be capital T dot, and capital T double dot if they were relevant to the situation, okay? To graph this thing, I want to, T equals, right? That's where I'm going to head. Now, you've got a couple of choices, right? Because you've got these points in time, right? You can define for yourself where you want this T equals 0 value to be. What are a couple of choices that would both make sense in this context? Anyone? What T equals 0 did someone start with? Let's see. Davin, what did you choose as T equals 0?
What?
T equals 0, that point there, or that time I should say.
Oh.
Okay.
Yeah, it's just 13, but it's like on the. I don't know.
I'm confused.
Wrong.
That's that. This is an open question. You really can set anything you like, depending on what phase you want to end up with. Did anyone else have something more concrete? Where did you actually begin? Savinda, where did you start? So you called 0, time 0, you called that 4 a.m. Yeah? Who else did that? I'm curious. Yeah? Hands up straight. Okay, a fairly small number. That's interesting. Where else did the rest of you guys put 0? What did you define it to be? Or did you? I haven't defined it yet. That's why I didn't put my hand up. Okay. The other alternative that I could think of that might make sense is you might call 0 midnight. You could do that. I think that would be fun. I'm going to put it as 4 a.m. I think that's a good choice. The reason why is if I had chosen it as midnight, right? What is the temperature at midnight? And the answer is I don't know yet, right? Like I don't have an equation yet. You'd have to work that out later. Whereas if I call it 4 a.m., where'd I put it? There it is. If I call it 4 a.m., I know what the temperature is then. It's well defined for me, 13 degrees. Let's put that in there. Okay, there you go, right? Now this will lead to a problem later on, namely that when we solve for values of t, they're not going to give us the time. When you've got t equals 10, it's not going to be 10 a.m. It'll be, well, in this case, if I said t equals 10 and we're going in hours, what time would that really be? That would be 4 a.m. plus 10 hours, right? So that would be 2 in the afternoon. 2 in the afternoon. So we'll have to watch for that. That's kind of a trade-off, right? Sometimes it's better to go the other way. To make t equal 0, some nice value so you don't have to worry about shift and that kind of thing. But right now, I don't know what this value is, so I'm going to stick with that. Okay? Great. What else can I put onto here? This is the lowest temperature, right? So it's going to go up from here. It's going to come up, and because it's simple harmonic, it's going to come back down, right? Okay, so now I have some points on here. This point over here. What time would that correspond to? That'd be 4 a.m. again. What t value would that be? That'd be 24, wouldn't it? 24, which is 4 a.m. again. Okay? In exactly the same way, I've got that stationary point up there. What t value would that be? That'd be 12, won't it? And that corresponds to 4 p.m. Now, what I'm doing here, I literally do this. If it was an exponential growth and decay situation, I would often have my t value, but then I'd have the year that it corresponds to underneath, right? You want to do everything you can to help you understand what are these numbers and what do they signify, because people trip themselves up on those, okay? All right, I'm almost there. What else have I got here? At 12, I actually know what this value is, right? So that corresponds to here, 23 degrees, okay? It's simple harmonic, right? So there's actually another piece of information that's implied onto this, apart from the points that I've got there. What's missing? Say that again? Yeah, the center of motion, the middle of the graph, right? It's not really a center of motion because nothing's moving, but you get the same idea. It's going to be halfway between your extremities, right? Which in this case would be 18 degrees Celsius, right? 5 degrees up and down. So there we go. Like that there. It's looking pretty sweet. Okay, so I have a graph now. And that's all I need. So this is defined for 0 to 24. Okay. So can we build an equation off of this? Can we build an equation off of this? It starts at an extremity, right? It starts at an extremity. So which of the curves are you likely to choose for this kind of graph? It'll be cos. Good. Okay, so I have that piece in place, right? Which extremity does it start at? It starts at the lower extremity. Then, well, it's not negative, but it's the bottom one, right? So that's going to mean the sign out the front should be negative, right? Okay, because it's an upside down cos curve, if you want. All right, what else is missing? I'm missing 3 numbers here. I'm missing 1, 2, 3. Okay, there's a t in there, isn't there? Okay, so what are these 3 numbers and what do they signify? They're all there. You tell me which one you want to do first. Amplitude. Okay, A for amplitude. When you look at this graph, what do you read the amplitude to be? 5. It's 5. It's how far you can go up and down from your center of motion. Good. So which number is that out of the 3? That's the coefficient of cos, isn't it? Okay, good. That's set. What next? Which one do you want to tackle after that? You want to do n? Let's do n. That's this number in the brackets, okay? What's that going to correspond to? And n gives you the period, doesn't it? Right? The period is 2 pi on n, whatever that n is. Right? Well, what is the period? It's 24 hours. Yep. Okay. So you can switch these guys around and cancel. I'm getting n to be pi on 12. Is that right? See what I did there? Pi on 12. Okay. One last number. What's it about? What does it represent? It represents the vertical shift, right? Again, if you like, the center of motion, okay? So the center of motion we already decided was up here at 18 degrees Celsius, right? So then this number should be 18. Because if you didn't put a number there, the center of motion would be the origin. Cool, we're done. Okay? Are we ready to tackle this question? We've got equations, right? I think we're good to go. So we want to know when these certain temperatures are, okay? So I can say it's going to be 18 degrees when this, which is temperature, is equal to 18. That shouldn't be too hard, right? Don't forget there's a domain restriction on this, okay? Let's solve it, shall we? First step. Don't stare at me blankly, Eddie. You can do this. First step. Okay, good. So you're going to get this. Okay, which is nice and simple. I don't need to worry about that -5 as it happens. Okay, so this is what I've got. Now, you should be able to see this in your head, right? There's my cos graph, and it usually ends at 2 pi, right? I'm forgetting about the fact that this has got a period restriction on it. Sorry, period. It's been compressed, right? If I want 0, where are these values? You know what these values are, right? 2 values, what are they? Pi on 2 and 3 pi on 2. Good. Okay, now you don't have to graph this unless, like me, sometimes you're like, oh, am I getting the right values? You just put it there. It doesn't have to be, it can be a really ugly graph as long as you're in the right ballpark, right? So now I have this. Okay, is that all right? So all I need to do is divide everything by pi on 12. When you divide this by pi on 12, that looks like 6. And when you divide this, that sounds like 18. Cool, good. So there are t values, right? Where would they fit? They would fit in here, 6 and 18. But of course, this has nothing to do with lowercase t or uppercase t or anything like that. We want a time, an actual time, right? So then you would say, well, I should say actually, i.e., like what does that equal to? Well, from 0, that's 4 a.m., so plus 6 hours is 10 a.m. And of course, that's 12 hours later, so 10 p.m. Ta-da, cool. That wasn't so hard. All right, you have a go at B. It's a little trickier because the number is a bit more awkward, but have a go and see if you get the right answer. If you do, call me over and I'll have a look. All right, sorry. I didn't mean that to get your attention. I'm actually literally clearing my throat. So how did you go? Now, let's compare notes. This is what you had to do. It started off just like the previous question, right? So you're like, okay, solve for 15. You take it over, the negatives cancel, and so you go cos inverse 3/5. You get out of decimal, but of course, if you just do cos inverse of 3/5 because of the domain of cos inverse, you are between -1 and 1, but you actually want to be between 0 and 24. So you divide by pi and 12, and out hop these 2 decimals, okay? Now, this is where most of our problems have crept in, okay? So here's what I've got. Now pay close attention, right? There's the actual decimal, okay? Now, the first problem that you might get is that you think, oh, cool, 5/4, 54 minutes. Oh, whoops, those aren't minutes, that's decimal, right? So that's your first problem, but that's easy to fix because all you do is you hit this guy, which is degrees, minutes, seconds. Okay, degrees, minutes, seconds. Oh, all right. How did you do it? Okay, now, let's read this together. Okay, now, don't forget, that's a t value. That's a t value, right? But I'm really interested in an actual time. So I should add 4 to this, shouldn't I? Since I started at 4 a.m. Okay. So what does this mean? It means 7:32, right? And then 31. Now what happens after minutes? Seconds. How many seconds are there in a minute?
60.
There are 60. There are 60. So 31 rounds up. Right? So this is really 7:33 a.m. Okay? If you went to the nearest minute anyway. And by the way, HSC questions love to do this kind of thing because it's so easy to... You're like, 31, of course it rounds down. Whoops. Okay, now, that's 1/2 the answer, okay? Then you have to get the other answer. Okay, well, how did you do that? Where did that 24 business come from? It came from... sorry, what did that 20 business come from? It came from 24 minus this. 24 minus, and if you were savvy, you would have used your variable notation in there and just put it in, so you could just go 24 minus that. And that's where this number comes from, okay? But just like before, to get from here to an actual time, you add 4, right? Okay. Now, those of you who struggle a little bit with reading 24-hour time, you know, this becomes 24.46. You're like, what is that? That's like that's 0. So what's that? That's like noon or something, right? So I saw. So here's the actual readout. Okay. I saw people say, well, okay, you got lucky. 28, it actually does round down because it's under 30 seconds, right? So you wrote down 12:27, okay? But then you're like, well, that's AM. I guess this is later, right? PM? Except it's not PM, right? Where would this be on this graph? This would be, here we go, all the way, and then just a little bit. But where is this? This is just after 4 a.m. because I can read it, because I wrote it, right? So this is actually not 4 p.m., which would be 12 p.m., which would be over here. It's actually going to be in the middle of the night. Okay? Which makes sense. You know, it's 16 hours after that. 16 hours, that's like a whole day, man. So you're back to being dark times. Okay? So there you go. Simple places, lots of little traps to fall into. Be careful. Okay?